Okay, this vignette will cover the basic ideas behind Git, how Git is useful, and give us a visual example of a complex project. So, what is Git? One major feature of Git is version control. Even a simple bioinformatics project can contain many different files and directories. So let's say our project has a data directory with subdirectories raw and interim. This is where our source data and intermediate files will be stored for the project. And actually, the data stored in these directories is probably bigger than we really want to include inside of a Git repository. So I usually make symbolic links to the full data, and it'll reside somewhere outside of the Git repo. We'll also have an output directory where all of our final tables, figures, and statistics will be stored, as well as a script directory where our scripts will be kept. And the root directory of the repository will probably also have a README file. This one is Markdown formatted. Now let's say that this copy is maintained on a server, and we have another copy for development on our desktop. Now we need to be very careful to keep things synced between these two systems, and this becomes even more complicated when we're working with another collaborator. Changes in different files may not be consequential if they're slightly out of sync, but they might be. But changes to the same file will almost certainly become a problem if the person on the left makes a change and the person on the right makes a change. Unless you use a tool like Git to manage those changes. It's very easy for a change from one user to get overwritten by another user. Git helps avoid these problems by tracking changes, and this might be done on the server or it might be done somewhere else in the cloud. Services like GitHub and Bitbucket are popular places to host repositories. So, how is this better than the alternative? There are more complicated ways of managing repositories using Git, but usually when we set up a repository, we'll copy all other clones from that original repository. When changes are made, we compare local copies to the original or remote copy. Let's say that this repository is hosted on GitHub. This is our original source repository. Now, when we want to work with this repository on a local machine, we will clone this repository and work with it on a desktop computer. When we make changes, we can then push those changes up to the remote repository. All these changes are saved, and if some new code doesn't work out so well, you can always go back to an earlier version. Just don't forget to push your changes up to the remote repository if you want them to become a part of the main repository. So here we have our Git repository and our local repository on our desktop. Another major feature of Git is ease of collaboration. We've talked about this a little bit. Perhaps we're now ready to upload our code to the server and try it out on some big data. So let's go ahead and clone our repository to the server and try it out. While that's running, we make some additions to our local code and push that up to GitHub. And we also find a bug in one of our scripts and we fix it on the server. The repository on the server is now one commit behind GitHub, and it has an additional commit to add. So if I try to push this commit now, Git will complain and request that I merge these appropriately on the server and try again. Luckily, the new file and the script change are both different files, so the merge is trivial. Just remember to push your changes up to the remote repository. Now, here we have another collision. Our local copy on our desktop, we've made a change in the same file that has been made on the server, and they're out of sync. When we pull changes down from GitHub, we're going to have to reconcile the difference between these two files. And then we merge these two commits, and then we can push that up to GitHub. And then we can sync that up with the server, and then everything's back again in sync. Let's go ahead and tag this commit as version 1.0 because we like it. And we've got a nice product that's ready to use, move to production. Another major feature of Git is that it helps us to become more organized. Our project is at a nice place now, but as is often the case, there are more features that we want to implement. Now we could just jump in and start to make changes, but what happens if we find a bug in version 1.0? Then we're going to be out of sync with our production again. So ideally, we want our feature development to be separate from version 1.0. So we'll create a new branch. Any bugs that surface in version 1.0 can be fixed without disturbing our feature development. And we can also push this feature up to GitHub so that someone else can clone what's on there, and they can help us with development, help contribute, and work together on this project. Now, once the feature is complete, it can be merged with the master branch and easily implemented on the server. This toy example illustrates the power of Git to facilitate collaboration and versioning of your project while keeping all of the complex details organized and well documented. Git is nice. It's a great tool. And I hope you have enjoyed this introduction to Git.